Hey everyone, welcome back. In this video, we are continuing our journey with Object-Oriented Programming, or OOP in short. Today, we are diving deeper into some key concepts, comparing abstract classes and interfaces, and exploring polymorphism in more detail. So, grab your coffee, open your IDE, and let's get started. So, you might be wondering, what's the difference between an abstract class and an interface? They both sound pretty similar, right? Well, let's break it down. Imagine you are building a robot zoo. Every robot animal in your zoo will have common behaviors. Some of these behaviors are predefined, and others need to be unique for each animal. That's where abstract classes and interface come into play. For abstract classes, an abstract class is like a partially built blueprint. It lets you define both the method with code or predefined behaviors and the methods without code, the unique behaviors for each animal. So let's do an example to see. Alright, now you create an abstract class, animal. The abstract class will have an attribute name for animal, and it has a behavior eat. This is a common behavior for every animal in the zoo, right? Every animal can eat, so we can simulate the eating feature by bringing out some text to the console. In here we will put a name is eating, and this is a common behavior for every animal or predefined behavior. Now we will create the unique behavior for each animal. We will create an abstract void make sound. Every different animals will have a different way to make a sound, right? So we just define, we just create a name of the method. So every class which inherit from the animal will define the code or the body of the function or the method. Okay. So now we will create a subclass or a child class for the animal. Maybe we have a dog. A dog is stands from the animal class, and in here you can see the dog must implement the method make sound because the animal didn't do that. Okay, and for dog, the dog will make the sound like woof woof, right? And we will define another animal, that is the cat. The cat also stands from the animal and also implement the method make sound, and the cat will make the sound different with the dog. It will be male. Very cute, right? And let's try this in the main method. In here we will create animal. So when you work with the inheritance, you need to you should manage the parent, not manage the child. That's why I use animal here to define the object type. Okay, we will define the dog for the animal, and for the instance we will create the new object by the dog class. And in here we will set the dog name Buddy, and we call the eat method, and we also call the make sound method. So let's run it. Okay, the dog Buddy is eating, and it makes the sound whoop whoop here. Now you can change the dog by okay, you can change the dog, or you create another object. You create a cat like this, and the cat will be Tom. Let's run it again. Alright, you can see Tom is eating, and Tom makes the sound meow here. So, summarize, in this code, the animal class provides a general structure for all animals, while the dog and cat add their unique sounds, right? Alright, so now an interface is like a contract. It doesn't allow you to provide predefined behaviors. It's all about defining the structure, right? For example, if all robot animals must have a way to move and communicate, we can use an interface. Okay, we can use an interface. Now we create an interface. Animal action. The animal can move, right? And the animal can communicate. And let's try to make the dog implement. In the last video, I didn't mention about the interface, which must use implement keyword to make an inheritance. And in this video, I noticed that you must use the implement keyword to make an inheritance from the class to an interface. Here we can implement from the animal action. And for the okay, before that we need to implement the method from the animal action for the dog class. Okay, we can do something here. Yeah, dog move and dog communicate. Alright, and before we run, I will create another thing. We will create another interface, like maybe flyable. Okay, flyable. flyable and a method fly. So if the dog want to be able to fly, you can implement a node interface for the dog like flyable, like this. So as you can see here, we can implement two interface. Java support you to inherit multiple interface on the same class like this. But for the class or abstracts, you cannot do that. Okay, you cannot extend from another class like this. You cannot do this. So please note this. All right. So we have the dog with the flyable and with the animal actions. And now, when we work here, when we are working with the interface, it's also when you work with an abstract, you can use the interface like this. You can get a group. You can group in a group that can group up animal action like this, and you made the dog, and here you can new the dog like this, and the dog can commute, and the dog can move. Okay, and let's run it. All right, you can see dog commute and dog move. So with interface, every class that implements animal actions must define its own version of move and communicate. It's like universal rule book, right? So when should you use an abstract class and when should you use an interface? Use abstract classes when you need to define both shared behaviors and unique behavior. Okay, you can see in the abstract class you share the defined behavior like it, and you create a unique behavior for every subclass, and use interface when you want to enforce rules and don't need to provide predefined behaviors. Think of abstract classes as having a base foundation and interfaces as strict contracts every must follow. All right, so now let's talk about polymorphism. It's one of the coolest features of OOP because it makes managing objects super flexible. Okay, with polymorphism you can manage objects of different child classes using their parent class. This helps you write cleaner, more reusable code. So let me show you. First, we talk about the managing parent, not child. In Java, you can create a parent reference that points to a child object. Let's go back to our animal example. Here, you can see. Okay, I will reverse the code for the animal. Okay. Here you can see we use the animal class to manage both dog and cat. We don't need to separate variable for each class like this. You don't need to do this. Dog, and cat is cat, like this. You don't need to do that. So it's easier when you want to manage an array of animal, right? You can create an array of animal like this. Animal equal new animal, 5 element, like this. And with and when you manage objects in an array, it's very easy to write and the code will be shorter, right? Okay, so this is why you need to manage the child, not the manage the parent, not the child. And when you work with an array of animal like this, if you want to sometimes you might want to check what type of object you are dealing with. For what we use the Instanceof keyword. For example, when you want to check whether the object is the dog or the class, you can use this. If the cat is instead of cat, right? When you can check like this, or you can check in the animal. You can create a for loop. Animal in the animal array in here, and you can check if the animal instead of the cat. You can do whatever you want with the cat. Sometimes in the cat you have a specific method. For example, in the cat sometimes you have a different method, like fighting. Okay, the cats very love to fight in each other, like this. And if the animal is cat, you can call the animal fight, like this. But if you don't use the animal instead of cat, and outside in the outside of the if state to check whether the animal is the cat, you do this. So sometimes the animal is dog and it doesn't have the fly method. So in that case, the program will be error or even crash. So be careful for this. Alright, now we talk about the overriding and overloading. So let's clear up two important concepts: overriding and overloading. Overriding happens when the child class change the behavior of a method from its parent class. Overloading happens when you define multiple methods with the same name but different parameters. So we can go to the cat and do something. Alright, and in the cat, sometimes you might want to make to override a method, like you can override the eat method like this, and you don't want to just show the name is eating. You want to make something different. Maybe you want to print I am cat with the name and I am eating, like this. And go back to the example, go back to the main method and see what to show when the cat call eat. Now the cat show you I am cat Tom, I am eating, right? But for the dog, it just show Birdie is eating from the parent class animal. So that is overriding. And now we will talk about the overload. The overload, in this case, it just makes, now you can create a method like maybe move without any parameter. And when you create another method with the same name and the same parameter, you can see an arrow appear here. Move method is already defined in cat. But if you put a parameter like this, you can see the arrow is disappeared. And if you do another with the same parameter, it will show you the arrow again. And when you put another parameter, the arrow will be disappeared again. So this is called overloading. Define multiple methods with the same name with different parameters. Okay, it's very good, right? And yeah, overloading is like having a Swiss Army knife with different tools for different tasks, while overriding is like replacing one specific tool with a better version. Alright, that's wrap on today's video. We explored the difference between abstract classes and interfaces, learned how polymorphism makes object management easier, and saw the power of overriding and overloading. In the next video, we are diving into more advanced concepts that will take your Java skills to the next level. And don't forget to like, subscribe, and hit the bell icon for updates. And if you have any question, just leave the comment to the comment section, and I will answer everything you want to know. Okay, thanks for watching, and I will see you in the next one.